This is Saudi Arabia, measuring a massive 2 million square kilometers, making it the 14th largest country by landmass. However, 95% of the kingdom is a hot, dry desert where you find lots and lots of sand. It is also one of the few countries where you find not a single permanent river. You're also looking at a country where the average annual rainfall is below 150 millimeters all year round. However, if you zoom in on the country, you will see something totally unexpected: arable land. Saudi Arabia is dotted by a network of farmlands where agriculture thrives, letting farmers harvest many kinds of fruits, an abnormality in the hot desert. You'll also immediately notice that most of the farmlands are in circles. The nation has 35,000 square kilometers of arable land, which is larger than the Netherlands and more than 3 times the size of Qatar. However, in the early 60s, Saudi Arabia only had 400 square kilometers of arable land. How did the oil-rich kingdom multiply its arable land in so short a period? Join us in this video as we dive into the ingenious methods Saudi Arabia has used to turn its desert into farmland oasis. Saudi Arabia might harbor lots of dunes of sand, but it's not always been this way. Approximately 10,000 years ago, Arabia saw a significant increase in rainfall and an expansion of lakes and vegetation which supported human settlements across the peninsula. In the millennia that followed, however, a series of extreme droughts led to drastic ecosystem changes. Humans would adapt and continue to inhabit the sandy country. Evidence shows that during the Dark Millennium, an arid period lasting from approximately 5,900 to 5,300 years ago, during which much of Arabia is thought to have been uninhabitable, there was human occupation at the Jubba Oasis. In other areas of northern Arabia, people constructed walls around oases, built landscape features to capture water runoff, and began excavating wells. While water is scarce on the surface, Saudi Arabia sits on reservoirs of water known as aquifers. This is similar to how the kingdom sits above massive amounts of crude oil. However, Saudi Arabia has been pumping out water from underground for years. Most of the water has gone to agriculture, where large-scale irrigation has made planting and harvesting possible. However, there is one problem with pumping water from below the ground. Aquifers can run out of water, especially when it supports large-scale irrigation like Saudi Arabia has been doing. To conserve its water, Saudi Arabia imported a technology, and it has made a lot of difference. The technology is center pivot irrigation. What is center pivot irrigation and where did it come from? In 1948, an innovative Nebraska farmer named Frank Zybach developed a new type of sprinkler system, the center pivot, which he patented in 1952. Center pivot irrigation involves using a mechanized irrigation system that can help to irrigate crops by maintaining a circular pattern around a central pivot. This actually explains why the farmlands shown at the beginning of this video are circular. The major part is a lengthy radial pipe that is supported by sprinkling towers. These towers pivot around a center point of the whole mechanism. The radial pipe itself consists of equally spaced nozzles to supply water to the surrounding crops. As the pipe gradually rotates, the water is uniformly released from the nozzles to offer nutrition to the crops. By using the radial pipe system of center pivot irrigation, the water travels along a straight line down the field. All the nozzles of the pipe have the same flow rate and cover the same area. This helps to ensure the uniformity of the water being applied to the crops. Centerpoint irrigation systems can cover as much as 130 acres in a straight system and nearly 155 acres in a swing-arm system, depending on the length of pipe attached. This makes the system suitable for large-scale agriculture. The design of this system is such that the sprinklers located near the pivot tend to cover a smaller area compared to the nozzles located at the end of the pivot. The main components in a center pivot irrigation system include the pivot point, which the whole mechanism revolves around. It is the area where the water first enters the pivot pipes. It is also the location of another crucial component, the control panel. The control panel contains the hardware that allows the farmers to operate the machinery. This is the brain of the setup from which the farmer can start and stop the machine, as well as change direction and change modes of operation, including running dry and running wet. There are numerous types of control panels available for center point irrigation currently. Farmers can pick up basic or advanced digital panels based on the budget and requirement. Other components include the drive tower or drive unit, which is part of the machinery that touches the ground, and it contains the accompanying hardware that allows for the movement of the system. It usually consists of wheels, a base beam, a drivetrain, and other important structural supports. There is also the tower box, which controls the drive unit, making the whole machinery move in the right direction and for the required amount of time. With center pivot irrigation, farmers can easily apply water uniformly all over farmland. It also greatly reduces the amount of labor needed during the harvest season. This solves two problems: high costs of labor and the inconsistency of farmhands. This irrigation method also helps to conserve enormous amounts of energy in the long run. In addition, it is known to be far more efficient when it comes to using water. It helps to prevent water runoff and ensures that the water bills incurred by farmers are greatly reduced. Moreover, using this system makes it easier for farmers to manage the water levels in their soil. The semi-automatic nature of this mechanism, coupled with the lateral movement of the sprinklers, makes managing water levels easier for farmers. It is seen that the efficiency of water application in center pivot irrigation is nearly 80%, and this is far higher than traditional methods. A center irrigation system is very versatile because it can water nearly every type of crop a farmer has. Then the same system can be used to sprinkle fertilizer, pesticides, and other necessary fluids. Approximately 2/3 of all irrigated areas in Saudi Arabia use the center pivot irrigation system. This has helped turn many acres of land into intensively irrigated agricultural land. The government's support and incentive for farmers to help maintain the country's food supply contributed to this shift. Initially, Saudi Arabian farmers complained of excessive corrosion in lateral piping of center pivot irrigation systems because they used a variety of water quality standards. To combat the problem, many farmers replaced the lateral high-cost steel pipes with polyethylene pipes that do not corrode. Polyethylene laterals, which are equipped with short drop tubes, were directly positioned under the standard steel pipe and above the ground surface at 150 to 200 centimeters. Farmers initiated this redesign with information drawn from their own experience and technicians, without even involving the center pivot dealers and designers that rely on a predetermined pressure for each sprinkler. Depending on the water's salinity, this replacement occurs every 3 to 5 years by the center pivot irrigation owners. In 1992, non-renewable groundwater supplies provided about 92% of irrigation water, accounting for more than 85% of overall national water use. As a result, the number of center pivot irrigation systems rapidly increased in Saudi Arabia. However, the center pivot irrigation system may be efficient, but it doesn't actually solve the problem. In the real sense, it only postponed the issues. This rise in irrigated land resulted in a notable increase in the strain on Saudi Arabia's water supply, causing problems with the availability. When intensive modern farming started, there was a staggering 120 cubic miles or 500 cubic kilometers of water beneath the desert, enough to fill Lake Erie in the US. But in recent years, up to 5 cubic miles or 21 cubic kilometers were being consumed annually on the farms. Virtually none of it is replaced by the rains because there effectively are none. Based on extraction rates detailed in a 2004 paper from the School of Oriental and African Studies in London, the Saudis were on track to use up at least 96 cubic miles or 400 cubic kilometers of their aquifers by 2008. Experts estimated that 4/5 of the Saudis' fossil water is now gone. Saudi Arabia has also witnessed some of its fertile land becoming an arid desert in modern times. That was the case in Al Baida, about 20 miles south of Mecca. The problem was that the inhabitants, known as Bedouin tribes, were obliged by law to settle in one area, a change that caused overgrazing and the gradual disappearance of native pasture. The community chopped trees down for sale as charcoal, and soon the once fertile land was nothing but rocky desert. Wells had to be dug further down to reach water, as the scant seasonal rains with nothing to contain the water on the land made flash floods that rolled away to the Red Sea instead of seeping into the soil to replenish reserves. The government then invited Stanford University permaculturist Neil Spackman and Harvard University bioethicist and futurist Mona Hamdi to try to reverse the change. Spackman lived among the inhabitants of Al Baida from 2010 to 2018. He built rock terraces and check dams and opening swales in the land, which helped in harvesting rainwater. Spackman and Hamdi used the ancient water conservation methods of ancient Incans and Nabateans to contain seasonal floods and train the water to flow as useful streams. In 2012, the project moved to planting drought-resistant trees, and by 2015, Spackman and the Bedouin planted 10 species of trees, 4,000 in all. Most of the trees died, but enough grew to give reasonable hope for a green landscape, providing foraging for bees and animals, windbreak, seeds from which to extract oil, charcoal, and soil improvement through fixing of nitrogen. The project would run into trouble when funding stopped and was abandoned for some years. However, when the rain fell again, the trees sprouted again. Perhaps one day the success at Al Bayda will be replicated throughout Saudi Arabia and the whole country will blossom with plant life. Let's hear what you think of Saudi Arabia creating greenery in the middle of the desert in the comments section below.